Today, we're going to be talking about InfraStake, the premier IR plastic staking technology. Our presenter today is Casey House. He's seated next to me. I'll turn the camera over to him once we get going. Casey is a technology specialist. He's been with Extel for how many years?
Over 10, yeah.
Over 10 years. And he's been living InfraStake ever since he's gotten here. So he knows the technology really well. And if you have questions about it, I'm sure he'll be able to answer them. And if for some reason neither of the two of us have the answer that you're looking for, we can do our best to answer those after the fact. I will be sending the recording of this webinar out afterwards, as well as the slides in PDF format. That'll probably come later this afternoon or tomorrow morning, depending on what happens with my afternoon. So with that, let's get started. Casey, take it away.
Hey, thanks, Jason. Hi, everybody. As Jason said, I'm Casey. Happy to spend some time here with you guys this morning, where I'm at, wherever it is during your day. But we do have a lot to get through. So I'm going to kind of dive in here. I do want to say that I'm going to try and stay a little bit general. So I apologize if this does not technically go as deep as you would like, but if you have questions that you would like to go a little bit deeper, let me know. But for the sake of the group that I've got here today, we're going to kind of keep this at the 500-foot level. So I'm not going to go through exactly all the lines on the slides, but I want you guys to be able to see what we are doing as far as an agenda. We are going to talk about what InfraStake is, how it works, what applications are well suited, what you might be running into that you could use this technology in, how to design parts for infra, and then we'll talk a little bit about our processing assistant and some of the components that are kept within the InfraStake modules themselves. So that being said, I'm going to jump right off. So let's start with defining what is InfraStake. So InfraStake is a staking technology that uses focused infrared energy in conjunction with a non-heated forming tool. We refer to that as a punch. I will probably slide into that terminology from time to time. So if you hear me say the word punch, I'm actually talking about the forming tool. We use this to mechanically retain a mating component to give you a strong, tight joint. Pretty simple. So before we get too deep, I'd like to share a video of the process. It's a short video. I'm just going to let it run, and then we'll talk about what we saw. Okay, so that's the basic InfraStake process. A lot of things happen during that process. We'll talk about that in a few minutes in an upcoming slide, but just kind of bookmark that in the back of your mind, what you just saw. We'll go deeper into that. So this, when we talk about InfraStake, I think it's important to point out that there are several staking technologies that are very common. We see these in the industry. We see hot punch, ultrasonics, hot air, InfraStake, and then NanoStake. These latter two, InfraStake and NanoStake, are Extel's proprietary technologies. We've developed both of those, but they're in the field with the other styles of staking as well. All staking technologies get you very similar results. They all have their challenges, but this slide demonstrates that we can get very similar results, if not superior results, using infrared over some of the other technologies. So let's talk a little bit about heat transfer. So there's three different ways that we conduct heat, or we transfer heat. Conduction, which is from one solid to another. A good example would be like what you see here is a video of butter being thrown in a hot frying pan, maybe touching a hot cup of coffee. You actually feel it from one solid to another. We also have convection, which is either through a gas or a liquid, like wind chill. That's another form of heat transfer. And then finally, there is radiation, which is it's electromagnetic wavelengths. So not dissimilar to, I mean, you'd see that or feel it, I should say, if you feel the heat from like a campfire on your face, or maybe even like sunlight. It should be distinct that we're talking about infrared, not UV, but the transfer method is very similar. So when we start talking about some of the challenges with different staking technologies, and then we hold that up against the forms of heat transfer, we talked about this as being very similar to like sunlight or the energy you would feel from a campfire. Infrared energy is affected by the amount of color, the amount of pigment in a material. This is unique to infrared energy amongst the other staking technologies. So basically what that means is, just like you would see with these two gentlemen, the darker the material, the faster, the more efficiently it absorbs the IR. Just like you would, if you had a black shirt on in the middle of August and it was 100 degrees out, you'd feel warmer than if you had a light colored or white shirt. We see the exact same thing with plastics. That's not to say that infrared staking does not work with all different colors. It's just we need to be aware that we may have different process parameters for a light colored material versus a dark colored material. Now you'll also notice this last bullet on the page, reflective surfaces. If we take this to an extreme, reflective surfaces just don't work. They don't work very well at all. Whereas we're trying to get the material to absorb IR, a reflective surface such as chrome or something like that, it'll just reflect it. Pardon me. And it won't absorb the energy. Diving a little bit deeper, and this is probably about as deep as I'm going to get into the conversation, is let's talk about the electromagnetic spectrum of light. So the lamps we use, and we'll talk about that in the next slide or two, are halogen lamps. They're using infrared energy to stake the parts. So that's measured in microns. And we're using the portion of the electromagnetic spectrum that's from 0.7 microns up to about 0.20. So it's a very large portion of the IR spectrum, but it's not what you see with the human eye. And then the closer we get to near IR, or to 0.7, the more efficient it is. So yeah, I guess that's really, we're not using the visual portion of the spectrum, we're using IR from 0.7 to 20. We talked a minute ago about the energy source. The lamps that are used in the InfraStake modules are tungsten halogen lamps. They are an industrial grade, not very dissimilar though from like what you would see in a headlight of your car, maybe in a flashlight or your work light. There's nothing really special about these other than they're an industrial quality. So there's 3 different standard models we use within the InfraStake offering. We'll talk a little bit about how we select them in a minute. But we use 100 watts in either a standard output or a high output, and then a 35 watt, depending on the module size and what your plastic needs as far as how much energy. Let's talk about the InfraStake process for just a minute. Very simple. We break it down to a 4-step process. And I'm going to start introducing some unique features at this point. You'll notice in this first step here, we're actually calling the first step of the process clamping. InfraStake is unique in the staking industry in the respect that the module itself is used as the clamping device. So that does a couple things for us. One, it makes sure that we have a tight joint at the staking location, and it eliminates the need to include auxiliary clamping in your part. So step 1 is we clamp the parts together in the InfraStake module. Step 2 of the process is where the staking process actually begins. We turn the lamps on, and you'll see from these red lines, the energy comes out of this lamp radially, and it's reflected off this reflector down towards your part. The concentrator, this gold cone at the end of the module, then concentrates the energy into your boss radially. So that does a couple things for us. That lessens the heat affected zone down here, because we're not heating from the top down, we're heating from the side in. So InfraStake works really, really well in parts that are sensitive to where that heat goes. In addition, you'll see that these blue lines here, those represent cooling air. So there's 3 process parameters that we use when we're doing infrared staking. We use how long we leave the lamp turned on, at what intensity we leave that lamp turned on, and then we temper that with a low flow cooling air. Those 3 processes working with each other will open the process window of your plastic. So what we're trying to find is we're trying to find that spot in your plastic that it is semi-molten. So not solid anymore and not liquid. When it's semi-molten, that's when we can work with it. So we use those 3 things to get your plastic to that temperature. Once it's there, we then move into the 3rd step of the process, which we call forming. The lamp shuts off, so we're no longer emitting IR. This internal forming tool, the punch, actually then extends. We're now taking your boss from a pre-stake position and we make it into the final dome or rosette, elongated dome, whatever the part requires. We put it into that position and then we hold it there. We hold it there until it resolidifies. You'll notice we've doubled these blue arrows. So we've now toggled from a low flow cooling air to a high flow cooling air. That helps us get this plastic back to a solid state faster. Once your plastic is resolidified, we then retract the punch. Notice that the module is still in the clamped position. So we're now using the module as a stripping plate. We retract the punch, and then once that's done, we retract the module. So one of the biggest benefits is the quality of the tightness of the stake. And if you notice, we're clamping it before, during, and after the process. Great question, Scott. I'm going to jump in. We just got a question about what is the average cycle time. It really is dependent upon the part. We have some applications that the bosses are really, really small, less than a millimeter, and we can do cycle times in 2 or 3 seconds. All the way up to bosses that are very large, think 10 millimeters. I mean, something that would retain maybe a door panel together or a pillar inside of a vehicle. Those could take up to 20, 25 seconds. It's really dependent upon the geometrics of the part and the material that it's made of.
Polypropylene is an example.
Yeah.
A door, like you saw the video of that tall boss that was being staked, that was polypropylene. And what was it? 4 seconds of heat and 4 seconds of punch.
Yeah, and we've got another slide. Scott just he further narrowed it in just a little bit. I got another slide coming up really, really soon that actually shows another process, and we list the cycle time right on it.
Yeah. So we'll have a couple examples of that. There was also some questions that came in about what's the purpose of the cooling air in the 2nd stage. It is, it is heating and cooling at the same time. It's important to know though, during the heat portion, the cooling air that's coming through the module is low flow. Yeah. It's not like blasting through. It's just a light air pressure that helps exhaust any fumes that are being generated off of the plastic, and it tempers the cooling, like Casey mentioned. There was a question that was asked a little bit earlier. AJ asked it, and I hesitated to answer it until we got to this slide. I'm not sure, maybe AJ, this answered your question, but the infrared process is heating the boss using the infrared light that's being focused onto the plastic. The punch is not heating the plastic and forming it in any way. Now it does draw some heat out. Yeah.
Well, and that's important to point out, because not only is it not heated, but that's one of the things that makes InfraStake work so well, is because it is not heated. So plastic naturally will not stick to a cool steel. So the punch is made out of stainless steel. So if we keep it cool, we prevent sticking. So that's a huge portion of it. Not only is it designed not to be hot, but it's used in the process.
Yeah. A couple other quick hitter questions here. The force and distance data, yes, it tracks that. We'll talk about that in a little bit. Yeah. And then is working with nylon with fiberglass. Yes, we can stake glass-filled nylon. And then the bulb life, Casey.
Yeah, great question. So I think I'm not going to go back to the slide. The manufacturer rates these lamps at 2,000 hours. So what that means is when they manufacture these lamps for a flashlight or for a headlight, their expectation is that they will last 2,000 hours of on time. So understand that's in a good environment. The InfraStake process, we're going to put it in an environment that it really was not designed for. It works really, really well in that application, but because we're not using it as it was intended, we have found that we need to prorate the life. Now, we prorate that at half. So all of our documentation says that you can expect about 1,000 hours of life on time out of a lamp. My practical experience over the last decade of doing this is that's very conservative. I think you're going to be closer to 1,500 hours out of a lamp. But this is what's important about that. When that lamp fails, and make no mistake, it will fail, it's very inexpensive to replace. They range from $10 up to $40, depending on the module. So very inexpensive. That's also the only consumable item within this module. So it's the only thing that we would expect that you would have to replace as part of the preventative maintenance.
Yep.
And it's somewhere between 1,000 and 1,500.
Yep. There's a few other questions here, but I think we're going to continue on because I think we'll probably answer a lot of these as we keep going.
Perfect. So here's that video that I was going to talk to you about. And there's, if you look down here in the right-hand corner, we'll look at cycle time. So I'm going to let it run. So there you go. That actually, Jason, nice video.
Yeah, thank you.
So you can see that that boss was a 1/4-inch boss, polypropylene, and we took 9 seconds to stake that. The lamps were on for 5 seconds. Punch extended for 4 seconds. Again, we don't just hit it with a punch and retract. We hold everything till it's resolidified. That's why there is a 4-second punch time there. So cycle time on that was 9 seconds. This is another video that I want to share with you guys. This actually, it proves out, if you will, that we're directing the infrared energy. I touched on this a little bit. Jason, he dove in a little bit deeper. Inside of this concentrator, that gold cone, we're not treating that like a little oven. We're very specifically and purposely aiming the infrared ray tracing at your part. This shows that. So I'm going to run it. I'm going to talk right over it, so I hope you can hear me. But what this is actually showing is we're taking the IR, turning the lamp on, reflecting it down into the concentrator, and then concentrating it on the part. You can see there's a huge air gap here. We're not using hot air. There is no thermal oven. Oh, and you can see we're actually putting enough energy in it that we can make that plastic semi-mold. So what you just saw there is what happens inside of the module, only we do it much faster and much more precise than a hand staking operation. So let's talk about benefits. I will say we're seeing a ton of questions pop up, and we'll get to those in a minute. Please don't think because I'm not addressing them right now, we won't get to them. We will. So let's talk about the benefits a little bit. We've talked almost to exhaustion about the tight staking joints, but we haven't talked at all about process monitoring. Yes, it does it. Depending on the module you use, we have everything from discrete I/O Hall effect sensors to linear potentiometers that use an analog signal to tell you exactly where the punch is during the process. It's a much lower cost than some of the other staking technologies. It's very safe. The modules do not get hot on the outside, so your operators, there's no burn hazard, that type of stuff. It's very strong, stronger than most staking applications just because of the method that we use. Very good, up to no A-surface marking. It's reliable, it's repeatable. I've dealt with customers over the years that use InfraStake for no other reason other than you just put it in and it just does it over and over and over. It just works. And it's higher quality. And energy consumption is much less than other staking technologies.
Maybe now would be a good time to answer a few of these. So can a metallized part, like an aluminum part, and transparent be welded? If you're actually staking plastic, if you're heating plastic up, then yes. But if you're trying to heat up the metallized part with the infrared energy, it won't work.
Yeah, it reflects the energy. So metallized, I envision that as some type of chrome plating.
Yeah.
Maybe that's a big assumption on my end, but again, if it's reflective, it's not allowing the plastic to absorb the IR.
Yeah.
So, what other question?
There's a question about the inside of the punch. What kind of material is the punch and what's the finish?
Okay, so great question. The punch is made out of stainless steel, and then we coat it with a gold coating. We gold plate it. It's not actually paint, it's gold plating. We do that in order to prevent the punch from absorbing the infrared energy. We need that to go into your part, not into the tool. So it's stainless steel. It does have a gold plating on it. The inside of that cavity may wear if you have a product with a high filler, like glass content, talc, something like that. You may see some finish deterioration after a large number of parts.
Yeah.
But
Steve asked, can the boss be solid, not hollow? Yes, and
Absolutely.
we'll talk through design guidelines for your part a little later in the presentation. Failure mode of the bulb just dies, right?
Yeah, and actually the system tells you when it does that. There is a monitor in the system. There's different levels of control. This system tells you, it monitors the voltage and the wattage pulled from the lamps.
Yeah.
So it'll tell you if there's an open short. In other words, a damaged lamp.
Yep. And the lamp decays a little bit in intensity over time.
It does. So, I mean, as you can imagine, with any lamp, as it gets hours under its belt, the performance is gonna slightly degrade. I mentioned earlier that we chose this industrial grade lamp because it shows in testing that it has less degradation than some. I would say probably more than most, or less than most, excuse me. But yeah, you would experience that. But there's also sensors within the system that will tell you when your stake is not complete, which basically means we've put some energy into the part, but not enough, which will be a big indicator that your lamp performance is starting to degrade.
Yeah.
And it's important. Some plastics are more susceptible to degradation than others. Polypropylene, for example, you'll be able to stake a lot longer on an old lamp than you would maybe a nylon or something like that.
A few more that I want to get to before we keep going on, and we're not going to answer all of them right now. We'll probably save some of these for the end. But forces. So the punch force is what, 20 pounds?
Max.
Yeah, okay.
So yeah, that's a great question. So if you take into consideration that we're using this module as the clamping device, InfraStake also has the benefit of being able to use a bunch of modules simultaneously. So we don't sequence them, we don't stick or stage them or shuttle them. We fire them all at one time. So we clamp with all of them. That's pneumatically controlled, how tight you clamp it. But then internally, we also extend or fire these punches all simultaneously. Long answer to your question of it's pneumatically adjustable, and it just needs to be enough to override the clamping force so that when all of the modules fire, we're not pushing the clamps off your part. But it's pneumatically driven. It can, if the system is turned all the way up, you can produce as much as 20 physical pounds of push per module. Does that make sense?
Yeah.
Or is that,
Yeah.
like
20 pounds of punch force, and then the module needs to be a little bit more than that clamping.
Exactly.
Yeah. And it can be a lot more than that if you want to. The module's quite strong, so it's like you can push really hard if you want.
Sure.
A couple other quick hitters that I can. Yes, you can mount it to a robot. We have that in our applications lab. And how close to each other? We'll talk about that in the design guidelines. Minimum diameter of the punch.
Well, we that's a hard question to answer because we machine it right down to the size of your part. So if you have a boss that's a 1/2 mil in diameter, we'll machine the punch so that it's just large enough so that the cavity will contain that punch. So
Okay.
it's part specific.
Yeah. Another question: have we tried heat staking PA12? That's the material used in HP multi-jet fusion 3D printing, which is something that Extol offers. Yes, and we've also staked the TPU material for MJF and
like rubber.
Yeah, and then the polypropylene MJF material.
Yep, it works.
All right. I think, can the system monitor current to detect a degradation of the lamp as preventative measure?
Yes, it can. You have to get there by setting your process parameters to show you when the punch has not traveled the distance that you would like, which basically means my part hasn't absorbed enough energy to become fully semi-molten.
Yeah.
So in a roundabout way, it will do that.
Okay. I think it's probably good if we keep going,
Yeah, I
and
think I need to move
we're going
on.
to talk about some applications now.
Sure, awesome. So we've been around for a lot of years. Ideally, we see most of our applications are in the automotive marketplace. Within that, interior trim, exterior trim, lighting, electronics, underhood. Yeah, I hate it when somebody just gets on and reads the slide, but that's what I'm doing. And then also, it's not on the slide, but the electric vehicle market is opening up all new types of opportunity for staking, whether it be radar arrays, batteries, that type of stuff. That is very much sweet spot business for InfraStake. We also do see business in the life sciences, so think medical devices, electronics, and then consumer products, office furniture, appliances, everything from countertop appliances to big stuff we see staking in. InfraStake works in all of those. So I've got 3 or 4 slides here that I want to very specifically talk about individual applications, and just maybe something that might jog some ideas of, hey, this might be something that we could use. These are all applications that we have done in the past that have real world results. So this was a solenoid cap that we did for Honda. And if you think about what we've been talking about for the last little bit, this may not look like a very good fit right out of the gates because it's nylon, which is a finicky plastic, and it's white. So we talked about white not being ideal. But there's a little backstory to this project. The customer was staking this with another technology prior to putting InfraStake in. And what was happening is their staking process was making this part hot, and it was potentially affecting the performance of the solenoid. So what they were having to do was build a conveyor system to cool down their parts, and they had a half hour-ish of inventory that they had to run, and they would spot check these parts to see if they had if it was affecting the performance. If they got one that was suspect, then they had a half hour's worth of inventory that they had to go through and spot check. By switching to InfraStake, it doesn't heat up the part. They were able to do their spot checks immediately after coming out of the staking application, and it worked really, really well. So their big savings really was not wrapped around the staking itself, but it was all of that inventory. So just a creative way that InfraStake was able to go in and save this customer a big hassle for sure. Door panels are something that we see a lot of. It's kind of a general statement, but big, heavy bosses that are made to hold together big, heavy interior parts. So we've developed one of the modules specifically for door panels. One of the benefits for InfraStake is we can run all of the modules simultaneously. So this is a small door panel. It's only got 35 boss locations on it. We see doors that have got upwards of 90, maybe 100 staking locations. And we can still do those all in one hit. So you can take an entire door and do it in less than 20 seconds, which is a huge advantage when you're comparing it to something that you have to shuttle or hit in multiple hits. This is a personal favorite of mine. This is an engine cover that we did for BMW. It's been a couple years ago now. But what's really cool about this part is there's 54 staking locations on it, and they vary in size and shape. And it was all done in one single action. So we did this entire door in less than 10 seconds out of nylon, which was a pretty finicky part. And then this is a little bit different. This is a light curtain. And if you look right here is the finished stake. The customer's challenge with this is they knew they had to stake on an A surface where their user, it would be exposed. And InfraStake was chosen specifically because of the ability to direct the IR to their boss only. We were able to not affect this textured pebble finish around it. So there's no other staking technology out there that can do this. And then finally, this is the last application I want to talk about. This was a medical device. This is actually a controller for an arthroscopic surgeon. So if you've heard of or ever known somebody that's had like knee surgery or something like that, this is the controller that the surgeon uses. When it was designed, it had staking locations on either end of this PCB, but then there was also a retention point right over top of this solder joint. Their existing staking technology was causing these to desolder occasionally. So these were passing or failing tests. They came to us. We were able to design an InfraStake module that staked only half of this boss. So we're staking this side, giving them some retention, but then protecting all of their solder joints by just leaving that part alone. So really cool application. There is tens of thousands of these things. It's a disposable piece, so every surgery gets its own.
Nice. We got the question, can you do multiple InfraStakes at the same time with different angles?
Absolutely, absolutely. So every InfraStake module is controlled independently. So even though they're all working simultaneously, if it's a press type operation, they may be all clamping to the part at the same time. Every module is individually controlled as far as how long the lamp is turned on, what intensity, and cooling air. We use flow controls, mechanical controls to control them individually.
So I think that answers the next question, which was, yes, different size and shape and even different colors. Every single module is independently controlled. Not that we have to have a different controller. The one controller can control each one of them independently.
Absolutely. And of course, if you do have different process parameters, your machine is only going to be fast as the slowest part. So if you have a part, we looked at that BMW engine cover a little bit ago. Some of those parts are black, some are gray. They can still all do them at the same time, but unfortunately the gray parts took a little bit longer to stake. So the black cycle time suffered a little bit. They were still able to gain cycle time because it was all done in one operation. So again, I've been with the company for over 10 years, but Xtol has been doing this for much longer even than that. InfraStake is part of our history. We've done it for forever. These are some of the big names that use it every day in their technology. Hopefully you guys recognize most, if not all of these. Maybe you guys' name is even up here. I haven't taken a full list of who's all in the room, but if not, maybe we could start talking and get your name up on this list.
Yeah.
So before I move into these guidelines, do you have any other questions?
There's one other that just came in. And so the banner light curtain.
Yeah.
How is it that we were able to clamp the part but not mark the part with the clamping?
Great question. We just adjusted the clamping pressure so that it just comes down and just touches off and holds the parts together. This part was obviously very, very small, so it didn't need a lot of clamping force. That's much different than if you have a component, maybe a dash pad or something that's like a cross-car component that is very susceptible to flexing. I mean, maybe we've all heard the term polywarp. Depending on your part, you may clamp it more or less depending on what that part needs. So that one just didn't need a lot of clamping.
Good. They're answering their own questions. Yes, the replacement bulb is somewhere between 10 and 40 depending on the module. Yeah. And yes, you can stake perpendicular angles at the same time.
Yeah.
Yes, you have a common controller to optimize cost.
Sure.
Yep.
These are great questions. So sorry, I can't see them on my screen, so I'm relying a little bit on Jason to keep me up and running. So let's talk a little bit about design guidelines. InfraStake, being as it's a little bit unique in the industry, we do like to see a recommended design. The question came up earlier, can we do solid bosses versus hollow? Yes, we can. Solid bosses, we would prefer that the dimensions for your boss is the height is equal to the diameter. It's a 1-to-1 ratio. When you get into hollow, we like that to be like a 0.8-to-1 ratio. And then it's important to understand through hole. We found that through hole is where you gain or lose the most amount of strength in a joint. Once you start getting that through hole larger than 10% bigger than your post, strength starts to drop dramatically. So in an ideal world, we would like that through hole to be no larger than 10% larger than the boss. We understand we have to put parts together too. So sometimes that needs to vary, but that's the sweet spot, if you will. I will tell you also that these design guidelines are available on our website. You can click them and download them, exactly what you're seeing right here, but with more detail on it. I've kind of trimmed it up a little bit for this presentation. We also do tab styles, and this gives you a little bit of dimensional thickness for those. The big thing is for tabs, this length needs to be less than 10 millimeters. If it gets more than 10 millimeters, it gets really difficult. It just won't fit. Talk a little bit about angles. This is the best design. This is the best design for any staking technology across the board. Parts flat together, perpendicular. That's ideally what we would like to go for. We understand that you can't do that in a lot of applications. So we also would suggest putting a standoff in if you could. Again, InfraStake isn't going to come down and clamp the parts together. This makes that a little bit more effective. We can do this type of design. We call it pour. The clamping is just not as uniform. It potentially creates shadows within inside of the concentrator. So we try to avoid this when we can, but it will still work. We just try to avoid it. InfraStake can produce multiple types of finished parts. Dome is what we would consider standard. The majority of the applications end up looking like this. However, we can do rosettes if that's what you would like. And then if you had a tab style, that would result in a elongated dome like this. All three of these are very common, but dome is by far and away what we would recommend. It's typically easiest to keep in process in production. And it's too deep of a conversation to go into for this conversation, but if you guys want to know more about that, look me up. I'd love to talk to you about it.
Great question.
We
Here we
just
go.
got a question about what materials work. It's like you're reading my mind. So yes, some plastics work better than others. Any thermoform plastic can be used with InfraStake. Any thermoform plastic can be used. However, some are better. Polypropylene, ABS, PC. I'm not going to read the whole list, but those are really, really good. We've got PA, nylon, PBT, TPO. They're listed as good. Certainly doable, very doable, but a little bit more finicky to dial in. Their process window as a material is just a little bit thinner, so it takes a little bit more attention to get them dialed in. You'll note on here that we put with fillers. InfraStake works just fine with glass filled, talc filled, even some of the more exotic fills that we're seeing these days. It works just fine. Again, bad materials, anything that's chrome plated, it will reflect the IR. Up to this point, we haven't talked about painted materials, but we should probably address it. If your bosses have paint or overspray on them, they will stake. However, that paint will affect the process. It affects how the IR is absorbed, and it creates inconsistencies in a production environment. So our general rule is, if you can, mask it, because that's going to give you better performance. Mm-hmm. I've seen some cases where painted just flat out doesn't work. I've seen other applications where a customer's been forced to have a painted boss and it works. It just means we have to clean the modules more often and deal with some inconsistencies.
Yeah. And by no means is this an exhaustive list of materials. It basically works with every single thermoplastic material. There's only one that's kind of challenging, and that would be PEEK, I would say, right?
Yeah. We can still get there, but you just have to pay really close attention when you're dialing in.
Yeah.
So there's a lot of questions about material that are popping up. They're coming up so fast that I can't respond to them. So
basically, so there was the HDPE. Yes, we can do HDPE. The fumes which generates during the process likely to deposit inside the punch and cause the process trouble.
Can we park on that?
Yeah.
I want to talk about that for a second. Short answer is yes, but let's dive into that a little bit. So if InfraStake, and I realize you guys are looking at a different slide now, you're looking at the different models that are available. But if InfraStake is in process, so in other words, we've set the machine up, we've dialed it in, and it's doing what it's expected to do, it creates very little off-gassing. However, like any other technology, you can change the process parameters, get it out of tune, if you will, and then it will create higher levels of off-gassing, which can result in soot or a layer. And then, yes, they will need to be cleaned. The very premise of InfraStake is that we need to keep all of the reflective surfaces clean because we need to be able to efficiently focus the IR. If we start to get buildup inside of the modules, that affects it negatively. So yes, short answer is it can affect it. The long answer is if the machine is in tune, that will be very minimal, very minimal.
Are adhesives bad? Have you dealt with adhesives in there?
I kind of categorize those just like paint.
Yeah.
It'll work. We're going to burn them off in the process, and that's going to result in off-gassing fumes, soot.
Yeah.
So it'll work. It'll just introduce.
There's a question about cleaning the punch. We typically don't need to clean the punch. It's more the reflective surfaces,
Exactly.
which is the concentrator and the reflector. And we'll show those so you can get the nomenclature in a little bit.
Sure.
Um,
Simple way. How do we clean those? You wipe them down with a non-abrasive cloth.
Yeah.
It's very simple. No tools are needed to disassemble them. They're very quick to be done.
There's lots of questions about how to clean. Maybe we'll have to play that video later on. Standard modules for develop. Yeah, we'll get into specific application questions and stuff like that. Maybe we'll follow up with you guys afterwards for some of those.
You know what? I'm kind of rounding third as far as my slides.
Yeah.
So I've got some slides to go through that talk about the modules and the components. Let's go through those real quick, and then we'll have as much time as needed to answer some questions.
Sounds good.
So these, what you're looking at now, are the 3 standard InfraStake modules that we offer every day. The IS32, which is the newest module. It's been around for a number of years now, but it is the newest one. IS125, if you guys are familiar with InfraStake, that might be the one you're familiar with. It's by far and away the most popular one over the lifetime of these modules. And then the ISM20, which is the smaller version. Very early on, we talked about 3 different styles of lamp. This IS32 has a 100-watt lamp. This IS125 has a 100-watt lamp. The ISM20, which is physically smaller, has a 35-watt lamp. So this module is developed to get into small staking applications. To give you a little bit of reference, this 32 is a 32 millimeter body diameter. This 20 is a 20 millimeter body diameter. So when you start talking about spacing, the smallest module we have is 20 mil in diameter. With each one of those modules, we have a standard set of components that go with it. We have different concentrators for the modules. Now we use these concentrators, we select which one goes with your module based on your part design. The parabolics inside of these are different. We use those in conjunction with different reflectors to be able to vary the focal points within the module. So you might see any of these on different InfraStake parts. We then also deal with applications that a standard concentrator will not fit on. So we do have the ability to design and machine in reliefs for avoidances. These are a couple examples. It's not uncommon at all. Probably 50% of what we sell from InfraStake has some type of modification made to it. In some instances, we'll just relief cuts and just let the IR escape. Again, we're not using the heat inside of this like an oven. We're using the ray tracing. So this is not as bad as what you think. However, in applications that are sensitive to that, maybe you have a surrounding part that we don't want any IR to get onto, or an operator that has a bright light issue, we would then laser weld in what we call a closeout or a doghouse into that part. This is very, very common as well. Then with inside that concentrator, we have punches. These are some examples of some of the punches that we would produce. Everything from a very standard dome. There's not a rosette on here as far as an image, but you can imagine what that would look like. All the way up through some pretty exotic, unique ones. This actually was staking 2 bosses simultaneously in one module. And then, of course, we also offer a custom line. This I don't have a photograph of. Most of the custom units that we do are specific for a customer application. Actually, all of them are by definition. So if your application doesn't fit into one of our standard offerings, just know that we can design a module unique to you. We've done this for a lot of customers. I want to get a little bit into the software. We've had some questions about controls, that type of stuff. This is what a very basic control screen would look like. We talked a little bit ago about how we control the process. Ramp time is any heating time that is done, heating time that is done at full power. Soak time is then time after that that is something that's less than full power. And then, of course, the power is at what percentage that is. So this is what you would see from a controller. We set how long we want it to be turned on at full power, if we want it to be turned on at a secondary level, and then for how long and at what intensity, and then how long we extend the punch. Very, very, very common. Every module is individually controlled. Of course, this is a generic screen, so yours would have your part name up here. All of the different modules would be numbered according to your part. We also have something that is pretty cool within the system. We have a processing assistant. What this does is the controller, through a series of really simple to answer questions, works with the machine operator by simple observation to dial in a process, either from scratch, and from the very beginning, you have a new part that you have no idea what it's going to take. You can have existing recipes that you could change. Maybe a customer changes a material or they change a color. That's going to cause the process need to be changed, or you can fine tune in an existing recipe. Very simple touch integration. It's 3-4 questions, and by an operator watching the system, the controller actually helps you dial itself in. This is what a typical monitoring screen would look like. What I think is important to catch out of this is these red barriers are user set. So you as a user can set what you call a good part or a bad part. We have screens for this that are wrapped around time, dimension. You basically tell the machine what is acceptable, and then it plots. This is the last, 35 stakes from left to right. So you can actually see trends and you can adjust it however you would like. This screen actually does boss height, which is before staking. And then we also do stake height, which is after. So we can detect short shots, broken bosses, that kind of stuff before the stake process even begins. That's it, Jason. That's all I've got for slides. So
all right,
I think we got some more questions.
Let's get these questions. So one of the ones that's on here is you showed the concentrators with machined out areas.
Yeah.
What does that do to your cycle time?
Good question. Anytime we remove reflective surface, it does impact the cycle time. It's hard to say specifically without an actual application. I guess I would say from minimal to a lot. I guess I don't have a way to narrow it down better than that. I will tell you that every module is specifically designed for the location that it's in. And if the engineering team, by the way, we have a dedicated engineering team that just does InfraStake. If they see something that says, hey, this is going to potentially delay cycle time a lot, more than 20% or whatever, we'll note that to the customer during the design process.
How is the process controlled to detect incorrect operation? Would that be just the punch position afterwards, or?
Yeah, I guess incorrect operation. Whoever asked that question, if you could hone in on that a little bit more. We do sense where that punch is during the process. So we can tell you if it traveled to its full extent and then retracted to its full extent. All of that we can tell through process monitoring.
Yep. Question more about how do we measure the boss height?
Yeah, great question. So essentially the module comes down, and then before the heat stake process starts, we extend that boss or the punch. So it comes down anticipating that it's going to find a boss at a certain height. If it finds that, it then retracts and continues on. If something varies outside of, again, a user set parameter, it throws a flag, throws a fault. This is cool. You didn't ask this question, but I'm gonna dive in a little bit deeper. When it detects that fault, you can tell it what to do from there. Just make a note of it, stop production. There's different levels of fault setting within the controller.
Nice. I'm going to take the slides and jump around as we answer some of these questions.
Sure.
If I already have a machine without the distance sensor, the LVDT kind, can we implement it? So the IS32 has a LVDT on the side of it. I think that's what he's asking. Can we add that to an existing machine?
You can. There's a little bit of complexity there because we're going from a discrete I/O system to an analog system. So some additions need to be made, but yes, you can do that. Something you will need to note though, the module, the analog module is about 2.5 inches taller than the discrete IO. So we would have to make sure that there's enough room in the tool.
Can clamping force be measured?
Yes. Yep. Now it's not. So maybe this is a good time.
Not really part of the module.
Right.
Yeah.
It's not part of the module, but certainly, yeah, you can measure how hard we're clamping it.
Yeah. How do the customized concentrators affect initial investment? So what's the cost difference there?
Great. Good question. Depending on a normal concentrator is like $375 to buy that part. If we have to make modifications to it, it could go up to like $575. So it could be more.
And in the initial purchase of the module, like when you're buying an InfraStake package or you're buying an InfraStake machine, does that affect the cost of the package?
No, it doesn't. We estimate it's kind of a unique process because every InfraStake product is designed around the customer's part. And during the quoting process, we don't necessarily know what that part, we know what it looks like, but we don't have all of the finite details of the design. So we take a swag at it at the beginning and then we run with it. And if we didn't anticipate that it requires modifications and it does, we don't change the part, the price. Excuse me.
Greg asked, are you detecting the boss height before the stake by the contact of the stake forming element? And yes, that's what we do. We fire the punch and it comes down and touches off on the top of the boss and says, here I am.
Yes, under regulated pressure. So we're not hitting it under full pressure. So if you had a tab style or a delicate, I guess is a good word, boss, we're not going to come just slam down on that part. We're going to adjust that pneumatically to make sure we don't damage your part.
Does InfraStake support interchangeable tooling for different parts in the same machine?
Yes, it does. Absolutely. And some of our largest users use exactly that process where they have one machine base, the controls all live therein, and then they just change out tools with applications.
Nice.
Our standard controller will control up to, I think 64 modules is the largest controller we have. So, yeah.
Nice. This is IR specific. Are there premieres that talk about nano and other technologies that you offer? Yes, we have a webinar that talks about NanoStake right now. We've done it in the past, so you can actually go to our website and watch that on demand. But I'm sure we will be doing that one again in the future. So you can stay tuned for that. Make sure that you are seeing our emails come through. Is there a standard dome height after forming? And does it change with boss diameter?
No, there's not a standard, because I say that kind of with a smile on my voice. It's not standard because we design it to what you want it to be. So if you have a do not exceed finish height or whether it be a height or a diameter, we design that into the process. So handshake, if you say, hey, for this one, I want like a flat top because I'm going to put a part over top of it.
Yeah.
We'll design that right into the modules for you.
Okay. Can the height measurement work as a good bad part stake check? So, detect that and then communicate that to an FIS system. So like a factory information.
Yeah, absolutely. Absolutely.
Yeah.
There's a little bit deeper conversation to get how to get there, but absolutely.
Well, I think we can go as far, like if you have an IS-32 module, we can go as far as measuring that final stake height and reporting that value back to your system.
Yeah, it's a data point. And then what you do with that is completely up to you.
Yeah. Let's see. I'm going to scroll through this chat and see if there's any questions that I missed. But if you have more questions, feel free to put them in there. And if I didn't read your question out loud and you're still wondering, please just type it again so that we don't miss it. Cleaning. We were going to show how to clean.
Yeah.
So let me navigate to that a second.
Yeah, so
I'm going to show, this is just one of the 3 module types, but it's this very similar process for all 3. So this, like Casey mentioned, you just wipe out the reflective surfaces.
So this happens to be out of an IS-32. The reflector and the concentrator slide out. Again, no tools. It's just got a detent ball that holds everything together. You pull these parts apart and you just wipe them down with a non-abrasive cloth. It is important to note that these are gold-plated parts, so you don't want to go in there with a brush or with something like that. That red rag that every maintenance guy carries around that's got metal flakes and who knows whatever in it. Please don't go after it with that. But generally what I tell customers when I'm with them is that if you treat this like your eyeglasses, you'll never have a problem. So
Yeah,
you don't want to scratch it up.
it's great. Also, another one that I'm going to quick show here. This is on the IS-32, how to replace a lamp. So it's fairly straightforward.
Yeah.
Again, you have to pull the stuff off.
This shows the simplicity.
Yeah.
Just like that.
Ta-da! I was your hand model in that. Sorry. Okay, a few more questions have come in. What is the radius of the forming punch?
Design to your part. So we have multiple blanks, I guess you would say, that we start with, and then we design this directly to your part. Maybe we should take just 15 seconds and camp on that. Every one of these InfraStake modules, although it's a standard product, the concentrator and the punch are specifically designed and machined for the staking position that it's being used in. So if you have a very small boss, we're going to design those portions, those internal components of that standard module for your part. So the short answer is it's going to be however big it needs to be for your part.
And as you can see on the screen, that affects both the shape of the stake, the size of the punch, the actual concentrator that we're selecting, and then whether or not we need to machine it. Everything, right. To Casey's point, is
this is
for the
not
punch,
stuff
for the
that
part.
You as a customer need to give to us. When we look at the data part for this, we'll put an engineering team on it, and they'll select all of these components, and then we put that in front of you and say, okay, this is what we see fitting in your application.
Yeah. PPE requirements, protective equipment.
You know, there's a potential for a little bit of off-gassing. I don't see a lot of machines that are vented, but you may want to consider it depending on what you have going on in your shop. The biggest thing is the modules don't get hot. They don't get hot enough so that they would be a burn hazard, but there's a pinch potential, a pinch hazard, because we're going to be clamping these things together. They're going to be on an end of arm robot. But yeah, it's not like a thermal punch where this thing's at 600 degrees for 12 hours during the day. Yeah, it gets cool right down.
Instead of that particular bulb, can you use an LED lamp? We've tried that.
Yeah, we have tried that. And yes, you can. We don't have it as part of the InfraStake offering because, quite frankly, the cost for LEDs was so much that it was it threw off everything.
Yeah.
So
keep in mind that you need, if it was an LED, you need the LED to have infrared output.
Yeah.
It's the light that you can see isn't doing anything for you. You need the infrared part of it.
You have to specifically buy an infrared LED, which are much more expensive than what we traditionally think of in the price of an LED.
Yeah. Any danger with exposure to the light with a handheld staking technique? Handheld modules.
Handheld modules. Really not a good idea. And we'll dive into it a little bit. The reason is InfraStake is really, really dependent on repeatability. The module needs to be oriented over top of the part at a specific angle, at a specific pressure every time. I mean, we've spent an hour talking about why it works really well. If you try to do that by hand, you take all of that out of the equation. So that's that portion of it. We wouldn't recommend it. Have we seen customers do it? Yes, with marginal levels of success. I do want to talk a little bit about the safety portion of it. Keeping in mind, this is a halogen lamp, which is the same type of lamp that's in the headlight of your car. It's a little bit smarmy for me to answer it this way to say, but if it's safe to look at the headlight of your car, it's also safe to look at this lamp. Now, I get that we're in a work environment, that kind of stuff.
Yeah.
So there is that issue. If it is an issue, we put tinted guards on machines, that type of stuff.
Now, I know that it's noon, so if you need to jump off, that is perfectly fine. We'll send out the follow-up email later on. And if you had questions that you still wanted to ask, you can reply to that email. So, but we can keep going with some of the questions. If you want to stay on, you're welcome to, and we'll try to answer a few more of these.
Sure. Also, before people drop off the line, I would love to have more personal conversations with you guys individually. My contact information was in the last slide. It'll come out
Boom.
after this. Please, if you want to talk more about this, specific applications, if you'd like us to come to your facility, talk to you guys about this, let me know. I'm happy to do it. I travel all over the world doing it.
Yeah.
I love to do it. And we can get much deeper when we talk specifically one-on-one.
Is there a pull force developed with different materials? So I'm thinking that's like strength data.
Yeah, we don't have a matrix. We don't have a developed matrix that says if you use this material of this dimension, you're going to get that much strength.
Yeah.
There's just too much variability from one resin to another.
How old is this technology?
20
plus years.
Yeah, 20 years old, older than 20 years old.
More than 20 years old. What would be the minimum gap between the modules in the machine? So if you have modules side by side, how close?
30 thou. 30 thou is what we like to put in there because you do have to have a little bit of room for adjustability and being able to take it apart to clean it.
But we have taken modules and sanded the sides of them down and smashed them together.
Yeah,
So if you
and
need to get it
it's not
closer.
ideal. You can't do it. Yeah. But
What's the biggest disadvantage of our system compared to hot air cold stake?
Well, because I guess I would say because it's so much more precise, the expectation is that it be more precise, and cleanliness. You have to keep them clean. I mean, I've seen hot air applications that are just 20 years old, they're dusty, they're dirty, they're just doing their thing. InfraStake won't live in that environment. You have to keep it clean.
Yeah. I think that we got most of the questions answered. If you see a few thank yous, you're welcome.
Awesome, anytime.
So, and yes, we'll send you a copy of the training material. We'll have a follow-up email, and you're more than welcome to reach out to Casey and see, if you want to have us come into your facility and talk with your team specifically, we can certainly do that. Real quick, as everybody's jumping off, I wanted to point out that we have all of these other technologies at Extol, and if you'd like to talk about any one of these, you can respond to the email that way, go to our website, use our contact form. However you want to get in touch with us, it's up to you. We're happy to talk with you about these and maybe see if one of these will work for whatever application you are dealing with. Couple more questions as people are jumping off. You're welcome. Thank you. All the thank yous. What is the maximum angle of infrared stake versus boss axis?
Perfect. Good question. 15 degrees is what we say is the largest recommended. So that's not to say that if it's greater than 15 degrees, that the project is not going to work. We say you can safely angle the module up to 15 degrees from parallel to your boss without having to worry about it. If you get above 15 degrees, we just want to look at the application and make sure that we're not running into anything strange.
Mm-hmm. What's the difference between InfraStake and NanoStake? Woo!
That is a huge conversation. Whoever that gentleman was, please send me an email. I would love to talk to you about it, but it's not a 2-minute answer.
Yeah.
It's just not.
Yeah. Biggest difference would be NanoStake doesn't use infrared.
Yeah, one is conductive staking versus one is infrared.
Yep. Great. Thanks, everybody. I appreciate you all joining and all the great dialogue and questions.
Yeah, this was fun. This was fun. It's one of the more fun ones that I've done.
It was very well attended. We appreciate that, and we really, really like all of the questions. As I said before, we'll follow up with all of you, and hope you all have a great afternoon. Thanks, everybody.